Okay, so let's start off with the new work on u-Substitution, and then as we go through the new work, I will revise what we did last time with the integration. Okay, so what is u-Substitution? U-Substitution is the first integration technique that we're going to be looking at. It is the simplest one, okay, so the easiest to understand, and it should be your go-to technique when you see an integral. So as we work more and more, adding more techniques, this should be the first one that you check for. Okay, then after this, there's a couple other ones, but this should be the first one you go for. Okay, so u-Substitution involves integrals that may look simple, like the ones we had last time, but if you look a bit close, it can be a bit tricky. Okay, so let's look at this first example. So we have the integral 2x square root 1 plus x squared dx. Okay, so already it looks a bit complicated. We've got a product of two things. We have not seen that before, right? All of the previous ones were either like simple roots that we could put as an exponent and then do the rule, or it was a polynomial, or it was a trig function. Here we've got a product of two things, and it's a bit confusing. So what we're going to do is a change of variables. So instead of writing this in terms of x, we're going to write it in terms of something else, and through that process, we'll see that this becomes a whole lot simpler. Okay, now how do we do that? The way I like to see it is the complicated part, so we have a square root, and then inside the square root we have something else. We've got a composition of functions. Okay, square root on the outside, 1 plus x squared on the inside. Okay, so sometimes that's not the case, sometimes it is a bit more difficult, but usually we let u, our new variable, be that inside part. Okay, that inside function, we let that be u. Okay, that's like a first step in this. Sometimes that's not the case, we'll see it a bit later, but that's a good starting point. We let u be that inside function there, and then we continue. Okay, so that's basically your first step that you should go to. So, let u be equal to this inside part. Okay, so that's the first bit. Second bit is that dx over there. So u equals 1 plus x squared, that handles all of the x stuff inside the integrand, so x goes to u, but dx we need to replace with du, right? If the inside variables are x, we have dx. If the inside variables are u, we need du. How do we get that? Well, we've got u equals 1 plus x squared. We can find the differential, like we did last semester. So the differential du, that's going to be du by dx. Remember that from last semester, the differential? So we've got u equals 1 plus x squared. We can calculate du by dx. Okay, and then we get du, which is what we need for the end bit of the integral. Okay, so what is du by dx? Anyone would like to answer that? So if u is equal to 1 plus x squared, du by dx is 2x. Good. Okay. Now, what's nice about this u-Substitution is that 2x dx, that is exactly what we've got over here. 2x dx. So when we make this replacement, we see that 2x dx is going to become du. The roots of 1 plus x squared will become roots of u. So it becomes a lot easier. Okay, so let's rewrite this a bit. So integral square root 1 plus x squared. I'm going to put the 2x on the other side just to make it a bit more obvious. Okay, so this is going to become the integral square root 1 plus x squared. Remember we said that was u. So let's just put u there. 2x dx at the top there, that's du. So now we can put du here. Now we've done this before. Okay, we've done this a few times. So the integral of root u du, we've done that before, it's quite easy. So all we need to do is write this as u to the 1/2. Okay. Now since it's u to the 1/2, that makes it even easier. We've got that exponent. We add 1 to the exponent and divide. So a half plus 1, that's a half plus 2 over 2, so it's 3 over 2. Divide by 3 over 2, that's multiplied by 2 over 3. So this becomes 2 over 3 u to the 3 over 2, and don't forget your plus c. Okay, so all we did here was the power rule that we covered last time. That was one of the rules. But we're not done, because this is in terms of u. That's what we put. We put the u variable. The question was in terms of x. We need to get rid of this u variable. That's what we put. We want to put the x back. How do we do that? Well, we just go back to here. U is equal to 1 plus x squared. So we can put that back now. So this is going to be equal to 2/3. That all stays the same. U, we said that was 1 plus x squared to the 3 over 2 plus c, and we're done. Okay, please make sure you include that last step. That u, we put that there, right? That wasn't part of the question. We came up with that. The x, that was part of the question. So we need to put any, whatever x function we have back in. Okay, so that's the process for these simple u substitutions. You have some outer function, you have some inner function. Most of the time, you can let u be the inner function, and once you've done with that, you can work around it. Okay, like we worked around that 2x part. Okay, that's for most of the time. Okay, you'll have something like that. Sometimes it will be a bit more difficult. We'll see with this last example, you might need to do a bit more work. Most of the time, that's the case. Okay, let's look at the next example. So here we have the integral x cubed cos x to the 4 plus 2. Okay, again, we've got a product of two things. Don't worry too much about that. What we're looking for is some kind of outside function, some kind of inside function that we can work with this u substitution. So ignore the x cubed. Don't worry too much about that. As you do more and more of these examples, it will become second nature to just ignore that and look at the inside right away. Okay, but for now, let's just block it out and see. Cos x to the 4 plus 2. Cos, that's going to be our outside function. We know how to deal with that. X to the 4 plus 2, we see that's on the inside. Since it's on the inside, that's a good candidate for u. Okay, again, sometimes it's not. This isn't always true, but it's a good start. So that inside part, let that be u. Okay, good start. Now, we've got u, so all of the x stuff we can replace with u. Now dx, we need to replace with du, which means we need to find du. So u equals x to the 4 plus 2, we need du. Now I'm going to write this out fully again. For tests and stuff, you don't need to write it out like this. If you just want to write du equals 4x cubed dx, that's fine. If you want to write it out step by step, that's fine as well. So du, that's going to be du by dx dx. Okay, again, please write that out the first few times. Afterwards, you don't really need to write that. Okay, so now du, the derivative, the 2, we don't need to worry about, that's going to go away. X to the 4 is going to come down, so it will be 4x, 4 minus 1, that will be 3. So 4x cubed. Okay, with this u substitution, there's going to be a lot of mixing between differentiation to find the du and integration once we found the du and we continue. Please do not mix up the different power rules, right? If you're finding du and you're doing a power rule, it's take down from the exponent minus 1. That's the derivative power rule. The integral power rule is add 1 to the top, and then divide. Okay, you're going to be doing both. Okay, please do not mix them up. Okay, if you mix it up, you get both wrong. Okay, so please don't do that. Okay, so we've got this 4x cubed dx. The x cubed is quite familiar. We've seen that before here. We've got x cubed and then the cos something. Okay, so we've got that. But here we've got a 4. In the question, there is no 4, right? It's just x cubed. So what can we do to just get our x cubed there? Okay, we can divide both sides by 4. So we can have here 1/4 du is x cubed dx. Okay, so just finding du like that, we get 4x cubed dx. That doesn't help us. We want x cubed dx. That's what's in the integral. So we can just divide by 4, and now we've got our x cubed dx. That's fine. Okay. People yawning already. It's so early. Okay, so again, integral, I'm going to rewrite it to make it a bit more obvious. So we have cos x to the 4 plus 2, and I'm going to put the x cubed dx on the side here, just to make it a bit more clear. Okay, x to the 4 plus 2, remember we said that was u. So we can just put a u there, that's fine. X cubed dx, just look at the previous line there, that's 1/4 du. It's fine not having just du by itself. Most of the time you won't get that. You'll get 2 du, or 1/2 du, or maybe u du. That's fine. As long as your x part matches, that's all we need. So x cubed dx, that matches what we have there. We can replace it with 1/4 du. Okay, so let's do that. So we have the integral cos of u, right? That's what we set our u to be. X cubed dx, that's going to become 1/4 du. So you put the whole 1/4 du down. Like that. Now this is easy. Forget the quarter, that doesn't make a difference. We're integrating cos. What's the integral of cos? Sine. Yeah. So that's going to be sine. And then the quarter, we just put that in front. So it's going to be 1/4 sine of u, don't forget the plus c. Okay, so for this period and then Wednesday, we're going to look at this u substitution with indefinite only. So that's all the plus c's. On Thursday, we're going to look at u substitution for definite integrals, and then we don't put the plus c. Okay, but for now and Wednesday, this is all indefinite. Okay, are we done here? No. This is in terms of u. We put the u there. We don't want that. So we're going to replace the u with the over here x to the 4 plus 2, like we had in the original question, and then we're done. So 1/4. Sorry, that's a 4 there. Sine x to the 4 plus 2 plus c. Okay, now we're done. So the final answer only has those x terms. Everything's fine with that. Okay, next one, fairly similar to this. We've got an outside function, we've got an inside function, and a little bit more work to do like we had here. So we have the square root 2x plus 1 dx. Okay. Now here we don't have a product of two things like we had before, but that's fine. We just continue as we did in the previous case. We've got an outside function, square roots of something. Okay. We've got an inside function, 2x plus 1. There's not much choice here, right? U is going to be that inside function. So u equals 2x plus 1, and then we see what happens. Okay. Now, I'm not going to write the full line for the next step. We're going to just do that in our heads from now on. So du. So it's going to be du by dx. Again, you don't need to write it. It's extra writing, not needed. The derivative is just going to be 2, so it will be 2 dx. Please do not forget the dx at the end. When you take your derivative, you might, write out your derivative and then forget the dx. You need the dx there, right? That's part of the integral that we're replacing. Okay, now if we go back to our integral, we've got root of u, right, after we do that, dx. Over there, we've got 2 dx. We don't want that. We want dx. So we divide by 2. So 1/2 du is dx by itself, which is what we need. If that top bit there was 2 dx, then we could just make the replacement as is. But since it's just dx, we need to find dx. Okay, which is 1/2 du. Okay, so same thing as before, let's do the replacements. Okay. So the root of everything inside now just becomes the root of u. dx, that becomes 1/2 du. Please don't forget the 1/2 when you are making that replacement. Okay, so the 1/2 we can take out, it's a constant. We don't need to worry about that. Root u, remember it's better to work with exponents, so that's going to be u to the half. Okay, same thing as before. Back to our old integration techniques. Quick recap on that. If we have a power, like u to the something, we add 1 to that power and then divide. Right? We covered that last semester. So 1/2 plus 1, that's like 1/2 plus 2/2. So it will be 3/2. We're dividing by 3/2, so that's like multiplying by 2/3. So that will be 1/2 times 2/3, u to the 3/2, and don't forget the plus c. Okay, remember from last time, if it's indefinite like this, no bounds means indefinite, you have your plus c. If you have the bounds, you don't need the plus c. Okay, we can simplify this. The half and the 2 at the top, they can cancel, so we're just left with the third. The u, we don't want that there anymore. We're going to put what we had before, 2x plus 1. So we put that inside. Again, to the 3/2 plus c. Okay. Okay, so that is the standard procedure for u-substitution. So for these past 3 examples, it was all the same technique, right? You've got an outside function, you've got an inside function. You let u be that inside function and work around whatever's left. Okay, maybe you need to divide by 2 or times by 4, whatever you need to do. Okay, then you integrate as normal and then go back to x. Okay, for this next problem, this is more of your test type problems, right? Here you need to do a little bit more work than what we have here. So here, the only work we had to do, if we go back here, we had the 2 on this side, we took the 2 over, and then it became a half, right? That's as much work as we did for this one. For this next example, it looks more difficult than what we did here, but it's exactly the same idea. We've got something like 2 dx, we don't want that, we want dx. We manipulate it so that we get what we want, right? So again, just think of that for this next example. It looks more difficult, but it's exactly the same idea. You're just manipulating what we have there until we have what we want. Okay, so this next example, okay, so this is more like what you would have in a test. Okay, root 1 plus x squared times x to the 5 dx. Okay. Now again, once you've gone through all the tutorials and everything, it will become second nature to just check quickly. So let's just check quickly in this case. What would happen if we let u be that inside part? Now we just think in our head. Before we write down, let's just think. So 1 plus x squared. Okay, so that's our u. Our du will then be 2x dx. Right, just quickly doing that mentally. On that side, we have x to the 5. but our du would be 2x dx. There we've got x to the 5. So you see there's a bit of a mismatch there. So whenever that happens, you know you're going to be doing a bit more work. Okay. Now we can still use u-Substitution, that's fine, but it's a bit more tricky because of that mismatch between the du and what we actually have on the side there. Okay, so let's let u be that inside and see what happens. So du will be 2x dx. Again, I'm skipping the du by dx, right? We can just skip that. We know what that means now. So that's du is 2x dx. Okay, but that's x to the 5. We can divide by 2 on both sides, and that will get us closer, but still a bit off. So 1/2 du is x dx. Okay, we're a bit off now. We've got x, and we want x to the 5. Now we think to ourselves, we're here at x dx. What do we need to get to x to the 5? What we could do is multiply by x to the 4. X to the 4 on both sides would make that right-hand side x to the 5. That's what we need. Now, we need to think, how do we get that x to the 4? Well, all we have available is u equals 1 plus x squared. That is what we have to work with, and that's the only thing that you should be using. So from that, we need to come up with x to the 4. That's not so bad. U minus 1 is x squared. U minus 1 squared will be x squared squared, which is x to the 4. Okay, so that's what you should be thinking. So let's go through that. So from here, we want x to the 4. That's what we need. We see we've got x, we need x to the 5. We need to use that first line and build up to that x to the 4. Okay. So let's start by minusing 1 from both sides. So we get u minus 1 equals x squared. Okay, close. Now we can square both sides. So u minus 1 squared is x squared squared. Now if you have x squared squared, the 2 and the 2 will multiply and become the 4 that we need. Okay. So we've got our x to the 4 in terms of u. Why is that important? Because on the right-hand side, we can multiply by x to the 4. That's fine, that's what we need. On the left-hand side, that's in terms of u. We don't want x's on the left-hand side, we want u's on the left-hand side. But that's fine, because x to the 4 can be written as u minus 1 squared. So, on the left-hand side, we multiply by u minus 1 squared. On the right-hand side, we multiply by x to the 4. Okay, does everyone see that? Okay, on both sides, we're multiplying by x to the 4. But on the left-hand side, we're writing it in terms of the u version. Does everyone see that? Okay, if you don't see that, you're going to be lost for the next bit. Okay, so everyone sees that. Okay, please don't be quiet about it. Okay, so let's do that. So on the left-hand side there, we're going to multiply by u minus 1 squared. Which is just another way of writing x to the 4. They're equal. But now on the right-hand side, we're going to multiply by x to the 4. We already have an x there, so it will be x to the 5. Okay. Does everyone see what I did with that? Okay. Now, why is this good? Well, if we look back at the beginning there, we wanted x to the 5 dx. Here, we've got our x to the 5 dx. And that left-hand side is in terms of u, so we don't have to do any more working with that. Okay, so let's do the replacement. So we've got our roots 1 plus x squared, x to the 5 dx. Okay, so the roots 1 plus x squared, remember we said u was 1 plus x squared. So we can just put u inside there. Okay, x to the 5 dx, we had that one line above. That's going to be 1/2 u minus 1 squared. And then the du. Okay, so now everything was changed from x to u. Now, it looks like we haven't simplified it much. We had a root and some power. Now we still have a root and we still have some power. So it looks like we haven't done anything. But this is simpler once we've expanded that out. Okay, once we expand the u minus 1 squared, we'll see that everything becomes the power rule. Okay, first let's take the half out. Integral root u, we write as u to the half. Okay, u minus 1 squared. As it is there, that's not going to help us much. Let's expand it out. So just binomial, we're going to have u squared minus 2u plus 1. Okay, again, doesn't look any easier than what we had before, but let's multiply the u to the 1/2 inside. Okay, so to make this a bit easier, because when we multiply in, we're going to have to be adding exponents. Let's rewrite these exponents with a denominator of 2. That will make it a bit easier. Okay, u squared, if we're going to write that as like with the fraction exponent, we can write u squared as 4/2. Sorry, let's write that a bit better. 4/2. Okay, that makes the u squared a bit easier to work with. 2u, that's 2u to the 1. We can write that as 2/2. And the 1, we just leave that. Okay, so when we're multiplying inside, we're going to be adding the exponents. So u to the 1/2 times u squared, we're going to have to add the exponents, but that's the same as adding 1/2 and 4/2. That becomes 5/2. So this just becomes u to the 5/2. Okay. So I've seen last semester a lot of you struggled a bit with the exponent adding. You know, if one of them is a half and another's 2, you make a bit of a mistake there. Okay, so I didn't punish you too much on that if you got the actual power rule correct. But here it's a problem when we're continuing. Okay, when there's questions coming up after this, it's important that we get this right. Okay. So if you do need to change your exponents to make it easier to add, please do that. Okay. It's perfectly fine to do that if you need to. Okay, so that will be u to the 5/2. Okay. Yeah, so I did see some people write this as u to the 3/2 because they quickly went 2 plus 1, and that's a 3. Okay. So, you know, maybe you're rushing and you make that mistake, but, you know, rather just take it a bit slower and get it correct. Okay, next one. U to the 1/2 and u to the 1, that's a 2/2, so that will be 3/2. Okay, and this last one, that just stays the same. Okay, u to the 1/2, that's fine. Okay, so the reason I say go a bit slower with that is because now when we're doing the integral, we need to now add 1 to the exponents and divide. If your exponents were wrong from the previous step, well, now it's very wrong at this step. Okay. Okay, now you lose your part marks because the previous step was wrong, now your power rule's wrong, and then your final answer's wrong. Okay, so please, if you need to go slow with your fractions and stuff, rather be slow than wrong. Okay, so let's do the power rule now. So we have 1/2. Okay. U to the 5/2, we want to add 1 and then divide. Adding 1 is the same as adding 2/2, so the first one becomes u to the 7/2. Dividing by that, we get 2/7. Okay, 7 minus 2, u to the 3/2. We want to add 1. That makes it 5/2. Dividing by that will be 2/5. Again, for this part, if you need to go slower, that's fine as well. Okay, u to the half, we add 1 in the form of 2 over 2, so it becomes 3 over 2, dividing by that becomes 2 over 3. Okay, and then plus c. Okay, so I still do that in my head. When I need to add 1 and divide, I go half plus 1, I need to add 2 over 2, so that's 3 over 2, divide, that's 2/3. Just go through those steps, don't rush it. Okay, so now we need to multiply everything by a half. We see that all of those terms have 2's. Okay, so those 2's are going to then cancel. So half times 2 over 7, that's 1 over 7. That 2 over there, that can cancel, so we're left with the 2/5. And then the 2/3, that 2 is going to cancel with the half, so we're left with a 1/3. And don't forget the plus c, because indefinite integral. Okay, are we done? No. This is still in terms of u. We don't want that, we want it in terms of x. So we go back to the top here, and we see u was 1 plus x squared. Wherever you see a u, we now write 1 plus x squared. No calculation needed, no simplification needed. All you need to do is replace. Okay, just replace. Please do not simplify your answer. Do not expand your answer. Don't write it differently. Just replace. Okay, so here we're just replacing. We're not even looking at the exponents. None of that. Just replace. So that's going to be, what was u? 1 plus x squared to the 7 over 2. Not even looking at the exponents, just writing it down. Do not try expand that out. Do not try simplify it. Don't try take the root. Just leave it like that. It's fine. Okay, minus 2/5, 1 plus x squared, 5 over 2, plus 1/3, 1 plus x squared, 3 over 2, plus c. Okay, please, with this, even if it looks like you can simplify, just leave it like this. Because on my memo, I don't simplify anything. I leave it like this, and I check, do you get it? If you try and simplify, you might simplify to a different way than I would try to simplify. And then I need to see, did you simplify correctly? Okay, maybe you simplify wrong, but your previous line was right. Now it looks like your answer is wrong. Okay, so rather just leave it like this. It's perfectly fine. If there is any follow-up question, I will specify, please simplify. The follow-up question needs it in simplified form. But if I don't say anything, right, it's fine to leave it like this. Okay, any questions so far? Okay, so this last example, this is as difficult as it gets. Okay, this is it. This is all of u-substitution. If you can do this last example by yourself, you can do any of the u-substitution. Okay, so please go over these examples again. Try to do them yourself. If you can do them yourself and you get the same answer, you're fine. Okay. Now, later on, we will be looking at more complicated techniques. So we'll have integration by parts, we'll have trig substitution, a whole lot of other ones. This should always be the first one you try. Okay, so while you're looking through your test paper and you see an integration question, you try this in your head first. If that doesn't work, try something else. Okay, this is always the easiest one to try first. The reason I say that is because with this integration later on, there will be more than one way to answer a question. Okay, so for example, that very first question, you can do it using integration, this u-substitution. You can do it using integration by parts. You can do it using trig substitution. Those other two are a lot more difficult than this first one, but you get the same answer. So I'd rather do it the easier way. Okay. Any questions on that? Okay. let's put some homework problems. Yeah, homework day 1. I'm so mean. Okay. I'm just putting homework so you can try it again. We will go through these now, and then you go try it again at home and see if you can get the same thing. Okay, so number 1, integral cos 2x dx. Okay, so we've done this one before, but that was just as a little rule that we had with the indefinite integrals. Now I want you to try it again using u-Substitution. Okay, next, x squared roots 1 plus x cubed. 3 integral sine squared x cos x. Again, with this one over here, this trig one, we will see this later as an example of a trig integral. So you can either answer this question as a trig integral question, or you can answer it as a u-Substitution, or even you can do it using integration by parts, which we will look at later. But please, try to use substitution first. Yeah, on that, in the test, if you do it multiple ways, I will mark you on each way. You can get more marks, right? Like we had last time. If you can do this question 3 different ways, say it's out of 5, you do it 3 different ways, all 3 ways are correct, you get 15 out of 5. Right? Okay, same as last time. Number 4, integral sine x roots 1 plus cos x. Number 5, integral x roots x plus 2. Okay. So I'll just give you a few minutes to go through this on your own, and then we'll go through the answers. Okay, you can work in teams, I don't mind. Yeah, just try that out. Let's do same rules as before. First person to get it right gets points. Or if you're working in a group points, right, you know the rules from before. Okay. But you do need to show all the working. You can't just put the answer down. Okay, again, I want to stress that that exam being 50% of your year mark, please make the most of your class mark. Okay. Especially with those points and the extra credits assignments and so on, please make full use of that. If you do fail at the end of the year, and I've seen that you don't have any points accumulated and you haven't tried any of the extra credits, I'm not going to help. Hey, sorry about that. Okay, just with regards to the YouTube recordings, so this has been recorded. I'm going to cut the recording now, just to let you work, and then I'll put the recording back on when we go through the answers. So if you are looking this up on YouTube later today, it will be in 2 parts. Okay.